Hello, today we'll be talking about molecular formulas, mainly naming individual ions. In this section we will not be covering writing chemical equations nor naming binary compounds. These will be saved for a later video. Naming nonmetal ions. In naming nonmetal ions, we take the original element, such as chlorine, bromine, sulfur, and nitrogen, and we add the ending "ide" to them, as you can see here in red. These ides, the ide ending, means that these elements exist on their own or in their ionic state. I wrote their ionic states on the right side. Chloride is the same as Cl negative. Bromide is the same as Br negative. Sulfide is the same as S negative 2. And nitride is the same as N negative 3. These letters over here, the Cl, Br, S, and N, aren't just taken as abbreviations. They are actually derived from the periodic table, where there are elemental symbols that represent each element. So where did these charges come from? They were taken simply by looking at the periodic table. Both nonmetals and metals follow a simple pattern of wanting to be like noble gases, or group 18, with a full outer valence shell of electrons. Simple counting can give us these numbers. Nonmetals gives us negative numbers, while metals, on the left side, gives us positive values. We simply achieve this by counting how many spaces it takes to get to the group 18 formation. However, transition metals do not work the same way. I will be talking more about transition metals later in this video. Some non-metal elements form a diatomic state. These nonmetals combine with each other in order to achieve almost a noble gas-like, more stable state. The elements that form these diatomic states are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and astatine. They are written with a symbol, their elemental symbol, and a number 2 subscript, such as the H2 for hydrogen. When writing chemical equations, elements are written in their diatomic form when they stand alone, such as in this formation of water. As you can see, H2 and O2 are both diatomic molecules, and they form water. We do not write them stand alone, such as H plus O leads to H2O, such as that way. That is an incorrect form to write it in, because this is the way they do exist naturally when they form water. In addition, astatine, as you saw where I put it before over here, is usually an unsure area whether diatomic or not. It's more of a gray area, but in this case I included it as a diatomic molecule. So as you saw before, there's a lot of diatomic molecules. So there is an easier way to remember this. It's a simple trick. It's this saying called, they start at 7, form a 7, and point to the other 1. What I mean by this here, if you take a look at the periodic table, here's number 7. The value 7 goes for nitrogen. So they start at 7, form a 7, and point to the other 1 over here. So they start at 7, form a 7, and point to the other 1. So that's an easy way to remember it. As you can see here, I included astatine again, just because it would make it easier to remember this phrase, and sometimes it actually could be considered a diatomic molecule, but as I said before, it's more of a gray area. So moving on to metals, these are for the left side of the periodic table. For most metals, their names remain the same. Sodium remains sodium, nothing is changed, nothing is removed or added. Sometimes you may add a charge if they stand alone in their ionic form, such as sodium forms Na+. You still call it sodium, it doesn't change to sodiide or anything, it's just sodium. Transition metals do not follow this rule. They can have different names for different charges, and yes, they can have different charges. So for transition metals, most of the time, parentheses are used and charges are placed within them. So this copper 1 basically means a copper with a +1 charge. This one's copper with a +2 charge. These charges are almost always positive values. So value inside the parentheses depends on the positive charge of the ion. I will explain the reason for these different charges in a later video. However, on occasion, some transition metals have formal names, such as copper 1, as I said before was copper +1, can also be called cuprous. However, from my experience, this naming was rarely used for me. I mostly seen them using the parenthetical style notation to write it in. And so that concludes my presentation, so thank you.